We'll start in about 1 minute. Later today, we'll start the review on sections 10.1, 10.2, and 10.3. But first, we'll finish 10.3. So yesterday we got to this equation in polar coordinates, r equals 3 times sine of theta. So what we can do is we can find some ordered pairs. We'll pick some theta values and then use the equation to find the r values, and then we'll plot them in as a polar curve. So to start with, let's just pick theta to be 0, pi over 2, pi, then 3 pi over 2, and 2 pi. When theta is 0, sine of 0 is 0, so the first r value is 0. When theta is pi over 2, sine of pi over 2 is 1, and 3 times 1 is 3. When theta is pi, sine of pi is 0, so the r value is 0 again. At 3 pi over 2, sine of 3 pi over 2 is negative 1. 3 times negative 1 is negative 3. And then when theta is 2 pi, sine of 2 pi is 0. 3 times 0 is 0. We'll begin by plotting those points. Okay, when theta is 0, theta 0 corresponds to the positive x-axis or the polar axis, but the r value is 0. So we plot this point. When theta is pi over 2, the r value is positive 3. So on the positive y-axis, we plot the point where the y value is 3. Then when theta is pi, the r value is 0 again. Okay, then the next theta value is 3 pi over 2. So 3 pi over 2 is 3/4 of a rotation. But since the r value is negative 3, we plot a point in the opposite direction, 3 units above the origin. So we're back at 3 again. And then when theta is 2 pi, we're back at 0. So that doesn't appear to be enough information to graph the curve. So let's pick some theta values between 0 and pi over 2 and see what happens. So I'll pick pi over 6, pi over 4, pi over 3. Hey, when theta is pi over 6, sine of pi over 6 is 1/2. 3 times 1/2 is 3/2. When theta is pi over 4, sine of pi over 4 is the square root of 2 over 2. So 3 times the square root of 2 over 2 is the r value. When theta is pi over 3, sine of pi over 3 is the square root of 3 over 2. So 3 times the square root of 3 over 2. Okay, so pi over 6, it's a 30-degree angle. Pi over 4 is 45 degrees. And then pi over 3 is 60 degrees. Okay, so along the ray corresponding to theta equals pi over 6, the r value is 1.5. So it's about there. Corresponding to theta equals pi over 4, the r value is 3 times the square root of 2 over 2. The square root of 2 is about 1.41. So 1.41 divided by 2 is 0.7, and 3 times that is 2.1. So approximately 2.1. So right in there somewhere. And then pi over 3, the square root of 3 is about 1.7. 3 times 1.7 is 5.1. And divide 5.1 by 2, we get about 2.55, 2.56, something like that. So right in here somewhere. Well, my drawing isn't very accurate, but the curve will do something like this, something like that, between 0 and pi over 2. Okay, it turns out that this is supposed to be a circle. So if we plot points from pi over 2 to pi, we'll complete the circle. And then, as we already saw one instance of a retracing, between pi and 2 over pi, the circle is retraced. And as I said, we saw the same point occur in 2 different instances. Okay, so that's the end of that one. So the circle is a circle. The center is at 0, 3/2, and the radius is 3/2. Okay, let's look at the next example. Graph r equals 1 plus cosine of theta. Okay, one technique for graphing polar curves is to first graph a Cartesian curve. That is, graph r equals 1 plus cosine of theta in rectangular coordinates, and then we can use that graph to graph the polar curve. So in rectangular coordinates, the vertical axis is r, and the horizontal axis is theta. So this is analogous to y equals 1 plus cosine of x, if you want to think of it that way or relate it in that way. So if we subdivide the interval from 0 to 2 pi into 4 equal subintervals, then each will have length pi over 2. So this is 2 pi, this is the theta axis. Okay, when theta is 0, cosine of 0 is 1, so the r value is 1 plus 1, or 2. When theta is pi over 2, cosine of pi over 2 is 0, so the r value is 1 plus 0, or 1. When theta is pi, cosine of pi is negative 1. 1 plus negative 1 is 0, so the r value is 0. At 3 pi over 2, cosine of 3 pi over 2 is 0. 1 plus 0 is 1. And then finally, when theta is 2 pi, cosine of 2 pi is 1. The r value is 1 plus 1, or 2. So in Cartesian coordinates, we see the familiar sinusoid. So we'll use the r and theta values to sketch the polar curve. Okay, starting with theta equals 0, the r value is 2. So theta equals 0 corresponds to the polar axis, or the positive x-axis. And the r value is 2. So this is a point. If we jump to theta equals pi over 2, the r value is 1. So pi over 2 is 90 degrees counterclockwise. The r value is 1. So let's look at the r values that correspond to theta between 0 and pi over 2. So at 0, the r value is 2, and then they start to decrease. So they're between, the r values are between 1 and 2. So the curve will do something like this. For theta values between 0 and pi over 2. Between pi over 2 and pi, so now we're in the second quadrant between pi over 2 and pi. There's a 0 at pi. So the polar curve will look something like this. So at pi corresponds to the negative x-axis. The r value is 0. For theta values between pi and 3 pi over 2, so now we're in the third quadrant. So the R value starts at 0. The R values are small, but they increase to 1. So when we get to 3 pi over 2, in the xy plane, this point is -1, but remember what we do with polar coordinates? For the angle 3 pi over 2, we're going to move 1 unit from the origin in the direction of 3 pi over 2. So we're at this point. Okay, then between 3 pi over 2 and 2 pi, we're in the 4th quadrant. So, and the R values increase from 1 to 2. So it's going to look something like this. The graph is supposed to be symmetric. My drawing doesn't look very symmetric. But the x-axis is like a mirror. So the top half of the graph should be a mirror reflection of the bottom half. So I might revise this a little. Something like this. This particular graph is referred to as a cardioid. Because it sort of resembles a heart. Okay, the next example, graph R equals 2 times cosine of 3 theta. Hey, there's a note about focusing the camera. Does it seem out of focus? It doesn't look like it's out of focus in the classroom. So if anybody else online, okay. All right, so this one, we'll draw the graph in Cartesian coordinates or rectangular coordinates first, and then we'll use that to draw the polar curve. Since we have 2 times cosine of 3 theta, you might remember this from trigonometry. If you write 0 less than or equal to 3 theta is less than or equal to 2 pi, and then divide each of those by 3, we get 0 less than or equal to theta less than or equal to 2 pi over 3. So what this means is in rectangular coordinates, the graph of R equals 2 times cosine of 3 theta has a period of 2 pi over 3. So between 0 and 2 pi, the graph of this in rectangular coordinates has 3 periods, each of length 2 pi over 3. Okay, so I'll go ahead and we'll sketch in all 3 periods. For each of those, we'll subdivide into 4 intervals. So this one is 2 pi over 3. This one is 4 pi over 3. And then the last endpoint is 2 pi over 3. Okay, well, it turns out that each of the smaller subintervals is of length pi over 6, or 30 degrees. So we can label those. This is pi over 6. Then 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6 is just pi. Then 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3. And then 11 pi over 6. Sorry, I mislabeled this last one. This last end point is supposed to be 2 pi, because 2 pi over 3 is already over here. Okay, the amplitude of this is 2 units. Okay, so if we just sketch the cosine curve, it's going to look something like this in the first period. And then it repeats itself. And then one more time. Okay, so you can see the R values oscillate between a maximum of 2 and a minimum of -2. So now we'll use that to sketch a graph of the polar curve. So since each of those subintervals is of length pi over 6, we'll subdivide the polar plane so that each one of those corresponds to pi over 6 degrees. Okay, so we start at theta equals 0. When theta is 0, the R value is +2. So this is a point on the polar curve. Between 0 and pi over 6, the R values are positive, but by the time we get to pi over 6, the R value is 0. So we get this part of a loop. Between pi over 6 and pi over 3, the R values are negative, and they go down to -2. So since the R values are negative, we have to sketch the graph in the opposite quadrant. So we're going to sketch the graph between these two lines here. Okay, but we're starting out at 0, and the R value ends at -2. So 2 units on this ray here is where we end up. Okay, the next interval is from pi/3 to pi/2. That's up here, but the R values are negative. So the graph is going to occur in the opposite part, the opposite sector. We're starting out at -2, but by the time we get to pi/2, we're at 0 again. So this is going to loop to 0. Between pi/2 and 2pi/3, that's this sector up here, the R values are positive again, and they go from 0 to 2. So the loop is going to end up at this point by the time it reaches 2pi/3. Okay, then between 2pi/3 and 5pi/6, that's this sector, the R values go from 2 to 0. So we complete a loop in that sector. So by the time we get to 5pi/6, we're at 0 again. Okay, then between 5pi/6 and pi, the R values are negative. 5pi/6 to pi is this sector. But since the R values go from 0 to -2, the graph appears in the opposite sector. So it goes from 0 to 2. Well, in this case, it turns out that from pi to 2pi, the same curve is retraced. Let's just take a look at one of those sectors. From pi to 7pi/6, the R values go from -2 to 0. So on the graph, the sector from pi to 7pi/6 is right here. And so the graph appears in the opposite sector, which is this sector. And it goes from, the R value is -2, so it's opposite, and then it goes to zeros. So I'll just sort of make a note of that. This retraces the graph that we saw between 0 and pi. Okay, let's move on to the next page. Okay, so now we'll talk about tangent lines. Given a polar curve r equals f of theta, think of theta as a parameter. Then the parametric equations of the curve are x equals r cosine of theta, but since r is f of theta, x is a product of two functions of theta, f of theta times cosine of theta. And the same goes for y. Y is equal to r times sine of theta, or f of theta times sine of theta. Using the chain rule, the same way we did using the parameter t, we can show that the derivative of y with respect to x is the derivative of y with respect to theta in the numerator divided by the derivative of x with respect to theta in the denominator. When we compute the derivative of y with respect to theta, we have to use the product rule because r is also a function of theta. Okay, so we all know the product rule. So the derivative, if we have y equals r times sine of theta, then the derivative of y with respect to theta is the derivative of r with respect to theta times sine of theta plus r times cosine of theta, which is the derivative of sine. And similarly, if x equals r cosine of theta, then the derivative of x with respect to theta, using the product rule again, is the derivative of r with respect to theta times cosine of theta. And then what we do is we add r times the derivative of cosine of theta. But since the derivative of cosine of theta is negative sine of theta, it appears as minus r times sine of theta. And finally, the derivative of y with respect to x is the derivative of y with respect to theta divided by the derivative of x with respect to theta. And we get this rational expression that we computed above. Okay, in the next exercise, we'll look for the points on the curve r equals 1 plus cosine of theta, where the tangent line is horizontal or vertical. Okay, so if dy dx is dy d theta divided by dx d theta, and this is true not only for polar equations, it's true in general for parametric equations. The horizontal tangent lines occur when the derivative of y with respect to theta is equal to 0. And vertical tangent lines occur when the derivative of x with respect to theta is equal to 0. So you probably saw that in that sort of thing in Calculus 1, just with like rational functions, for example. Okay, so first let's focus on the horizontal tangent lines. So the formula for the derivative of y with respect to theta is the derivative of r with respect to theta times sine of theta plus r times the cosine of theta. Okay, but since r equals 1 plus cosine of theta, first, the derivative of r with respect to theta is negative sine of theta. And then by substitution, we replace dr d theta with negative sine theta. So we get negative sine theta times sine theta. We're going to replace r with 1 plus cosine of theta. So we get the quantity 1 plus cosine of theta times cosine of theta. So negative sine theta times sine of theta is negative sine of theta squared. And then we'll distribute multiplication to get plus cosine of theta plus cosine of theta squared. So let's remind ourselves what we're doing. Since we're computing the derivative of y with respect to theta, we're going to set it equal to 0 and determine the theta values at which the derivative of y with respect to theta is equal to 0. And those will give us the candidates for the theta values where the tangent lines are horizontal. Okay, but we have a little bit more work to do here. Let's replace negative sine of theta squared with something that's in terms of cosine of theta squared. So sine of theta squared is 1 minus cosine of theta squared. So we have the negative of 1 minus cosine of theta squared plus cosine of theta plus cosine of theta squared. And when we do some arithmetic, we're going to find that we have 2 times cosine of theta squared plus cosine of theta minus 1. And now we'll set it equal to 0. We can factor this 2 times cosine of theta squared plus cosine of theta minus 1. So the 2 factors will be 2 times cosine of theta and then minus 1 times cosine of theta plus 1. Okay, the product is 0 when each of the factors is 0. So 2 times cosine of theta minus 1 is 0 when cosine of theta is 1/2. And let's see, cosine of theta equals 1/2 when theta is equal to pi over 3. And the other theta value between 0 and 2 pi, where cosine of theta is equal to 1/2. So in the fourth quadrant, 5 pi over 3, right? And then cosine of theta plus 1 is 0 when cosine of theta is -1. And that occurs when x equals equals pi. Okay, so we're making the claim. If I'm wrong, you don't have to make the claim, but I'm claiming that on the graph of r equals 1 plus cosine of theta, there are horizontal tangent lines that correspond to theta equals pi over 3, 5 pi over 3, and pi. This is the graph that this is the polar equation that we graphed a couple of minutes ago. So here's the graph. Of r equals 1 plus cosine of theta. So corresponding to pi over 3, well, according to our calculations, we should have a horizontal tangent line at pi over 3, and then also at 5 pi over 3. So that looks believable. Tangent lines that correspond to pi over 3 and 5 pi over 3. And what about theta equals pi? Yeah, I think so. Theta equals pi. The curve comes in, and by the time it gets to 0, the tangent line is horizontal. So I believe that theta equals pi. Okay, for the next part, I'll leave most of the rest of this for you to do. To find vertical tangent lines, we want to find where dx d theta is equal to 0. So let's at least set it up a little bit. So according to the formula above, dx d theta is dr d theta times cosine of theta minus r times sine of theta. So we saw earlier, okay, so r is equal to 1 plus cosine of theta. And so dr d theta is negative sine of theta. And then we make substitutions. So we get dx d theta. Dr d theta is negative sine of theta. So we get negative sine of theta times cosine of theta. And then minus r, which is 1 plus cosine of theta. Multiply that by sine of theta. And we'll do a little bit of arithmetic. We get notice we're going to get negative 2 sine of theta cosine of theta, because we're subtracting sine of theta times cosine of theta. So altogether we get negative 2 times sine of theta cosine of theta, and then minus 1, or minus sine of theta. which is equal to 0. We set it equal to 0. And another thing we can do, just multiply every term on both sides by -1. And we can think of this as +2 times sine of theta, cosine of theta, plus sine of theta. I'm technically incorrect by saying that this is dx d theta. I'm just thinking of what we can do once we set it equal to 0. When we set it equal to 0, we can write it as 2 times sine of theta, cosine of theta, plus sine of theta equals 0. And then factor sine of theta out, and we get 2 times cosine of theta plus 1 times sine of theta equals 0. And now we can determine what theta is. 2 cosine of theta plus 1 is equal to 0 when cosine of theta is equal to -1/2. So for which values is cosine of theta equal, which theta values is cosine of theta equal to -1/2? So cosine of theta equals -1/2 in the third and fourth quadrants. So when theta is 2 pi over 3 and 4 pi over 3. Sine of theta is 0. When theta is 0 pi or 2 pi. Okay, let's look at our graph. So this time we're looking for vertical tangent lines. So 2 pi over 3, 4 pi over 3. And well, for sine theta, these can't be the same. Remember at pi, we found a horizontal tangent line. So we can't have both horizontal and vertical at the same point. Okay, but let's take a look at the graph. Okay, and I think it's believable. The 2 pi over 3 is about right here. It's 120 degrees, and it looks like we have a vertical tangent line there, and then also 4 pi over 3. That's in the third quadrant. We have another vertical tangent line. And also a vertical tangent line corresponding to theta equals 0 and 2 pi over here. Okay, we are almost out of time. We can at least look at the first problem on the review for sections 1, 2, and 3. So this one says, sketch the curve by eliminating the parameter. But first, note, since y equals the square root of t, t must be greater than or equal to 0. And one way to eliminate the parameter is to solve for t. In this equation, x equals t over t plus 2. So if you multiply both sides by t plus 2, we get x times t plus 2x equals t. And then tx equals t minus tx. Factor the t out, you get t times 1 minus x. And so t is equal to 2x over 1 minus x. Okay, we're out of time now. We'll do more work on this on Monday. So go ahead and sign in for attendance.